Got it. Okay. So let me check one other thing. I'm gonna hit done here. Go ahead and get this student. Wait a minute. Mr. Palmer, I don't see you on my roster. Are you sure you're in the right time? I just don't see you on my roster. So you definitely want to either check. You might have to contact the registrar, Mr. Palmer. You're the only one I don't have. Like, are you in the right time, or do you have a different name? All right, let me put him back in the waiting room.
I'm checking it right now.
Okay. Okay, Zoom user guest, you either need to DM me so I can identify you. So there's only two that I don't have on my roster. Whoever Zoom, I don't know who Zoom user guest. Okay, Telemake, I found you now. I guess you updated it, and then I think Mr. Palmer is getting to the bottom of his. Yeah, that's important. Like, you want to definitely make sure, like, that you're on my roster, because I'm pulling this from Blackboard, and because if you're not, it could really mess stuff up. I think we are streaming. Strong. Totally temperamental. Let me get this to that.
This is College Algebra 1.
This is College Algebra 1.
Yeah, I'm supposed to be here. It's probably because my Blackboard isn't working.
Yeah. Okay, don't worry about it right now. If your Blackboard isn't working, just try to get that up to date as soon as possible. Hang on. Maybe it's this. I might have to reboot it. Just reboot this real quick. I'll be right back. Mute the screen. Let me make sure that I'm streaming. It seems like it's working now. Okay, so it is streaming. And I did just let someone in that has a Zoom user guest, so you have to identify yourself to get credit. And as a general rule of thumb, you definitely want to just go ahead and update it so it shows your student name, because I typically take attendance as I let you guys in.
Oh,
so there's
sorry.
at least one student. Go ahead.
Sorry, I registered for for this class today because initially I was in a different class.
Yeah, I have you on my roster. I got you. So, Gene, there was another one, but it doesn't look like it's there anymore. So let me see. Franklin. Yeah. Okay, I think I got everybody. All right. So let's see. Let's kind of start here. We just start on this blank page. So as far as announcements, so I do take attendance as I let you guys in. I let you guys in one by one, and I take attendance as I let you in. And if I'm not finding you on my roster, I usually try to bring it to your attention immediately. Just as a reminder, I do have it set up to where this is remote asynchronous, where you're not obligated to stay. All I need on you guys in is just to get your attendance credit each day. So once you've made it into my Zoom, that means you've gotten your attendance credit. You're not obligated to stay. These sessions are live streamed to my YouTube. And with this being remote asynchronous, my real intent is for class time to be like a Q&A or a study session. If there aren't specific questions from the homework or quizzes or exams, then I'll take class time to go through as many either examples. I'll go through as much as the lecture as I can, which is already on my YouTube, or I'll try to go through as many homework questions. I typically will start with the lecture, but then if somebody's like, hey, can we go through the homework? Then I'll shift gears and we'll spend time going through the homework. If you have questions for anything pertaining to the course, you just got to get my attention and we can stop and we can talk about it. But again, the full lectures for the things that I kind of am about to say are already on my YouTube. For instance, today I wanted to just go through section 1.1, graphs of equations. Also, if you're just joining us, so this is College Algebra 1 with lab. For the lab component, you want to seek out Dr. Lamar. So you should be able to see my screen. If we go to the landing page, well, it's going to be the same thing. Actually, no. Let me go to the right one. So this is with the lab. This is my second one, which is this one. So this is our landing page when you go into Blackboard. If you're just joining, to access the lab, and basically the lab is going to be run by my colleague, Dr. Lamar. And so here on the left-hand panel where it says Online Alex Lab, you click on that and her information is there. You want to reach out to her and everything that she tells you to do, that's what you need to do. And she's basically going to give me a grade and I'm going to take whatever she gives me and I'm going to use it to scale it to account for 10% of your overall grade. For us, for my course, this is the landing page. And when you open this up, basically we're using My Math Lab and that folder number 4 that says assignments. Right, if we open up that folder, and then My Math Lab is that first link there, right? So when you click on all assignments, you're going to be prompted for payment. I think that Pearson runs about just under $120. This is College Algebra 1. Let me make this statement. So going forward, like beyond this class, if you take any other class that also uses Pearson and is using the exact same book, then you don't have to purchase Access again. And I want to say that I teach 3 different courses, consecutive courses that use the exact same book. And I use Pearson. So it's like for College Algebra 1, College Algebra 2, and I think pre-calculus, we use the same book as well. So if you were taking me, which more than likely I would be using Pearson, and it should be, again, it's a high chance that it'll be the same book. That one purchase should be good for just about 3 courses. College Algebra 1, College Algebra 2, and pre-calculus. What did I hit? I hit something. That's fine. I don't know why this won't suppress though. That's like getting on my nerves. Let's try this. This is like it's working now. Okay. Yeah, Zoom is kind of, I don't know, the device is kind of be throwing a little bit of a tantrum, but it's fine. It seems like it's working now. So again, I'll probably go through as much of the lecture as I can, but if somebody requests to go through the homework, we can go through the homework. And also you can ask about anything that's on Pearson, any homework assignment, any quiz, and any exam. Also as a reminder, all of our assignments, we get unlimited attempts. The homework and quizzes are due on a weekly basis at Sunday night at 11:59 p.m. It's basically midnight going from Sunday to Monday. But you can work on any assignment past the due date with only a 10% late penalty. So, for instance, the information for week 1 was due last night at midnight. So for section 1.1, but again, you can work on it all the way up until the very end of the course with only a 10% late penalty. Okay. So let's take some time and start making our way through section 1.1. Again, we'll do as much of section 1.1 today as we can. But again, this presentation should already be on my YouTube. And in order to access my YouTube, if we hop back over to Blackboard, and if we go back to the landing page, so I'm landing page, right? If we open up this folder, and then at the very bottom, it says a Beautiful Mind Phifer. So you click there and it'll take you to a playlist that has like these full lectures already there. Okay, sorry. Yeah. So the late penalty is very small, right? For right now. Screen share. Oh no. Screen share. Start the broadcast. Okay. And let's look at the chat. Do we have anything due today? Our weekly assignments are due Sundays at 11:59 p.m. So there was something due yesterday. Even if you're just joining us, it's a small late penalty. You can still earn up to 90%. And you're only missing out on 1 point of your overall grade, right? So right now it's a very small weight. It's not gonna affect you that much. How do we access that assignment from yesterday? It's on Pearson, right? So you got to gain access to Pearson, which is what we talked about earlier. And yeah, the late penalty holds. Yeah, that's too much to try to be doing all that other stuff. And it's not going to affect you that much. Okay. All right, so let's take some time and go through as much of the section as we can. So this is section 1.1, graphs of equations. And so some objectives here, we like to plot points on a Cartesian plane, find the distance between 2 points, find the midpoint of a line segment, sketch a graph of plotting points, find the intercepts of a graph, find the symmetries in the graph, and find the equation of a circle. So again, with a lot of this information, the more organized you are, the better, right? So the recommendation is to be taking notes as if you're in class. I can make a copy of, and I do intend to have like a couple of different versions of the notes become available. Like I want to go ahead and load the student version of the notes where, you can pull the notes up in advance. And it's going to be pretty much the same thing, but each example is just going to be just a question with no supporting documentation. And I want you to try to attempt those before we meet. And then once we meet, we'll try to get through as many of those as we can. And I'll try to fill in some of those missing details. And I don't think it's available just yet, but I'll make it available where you can access it. But I think it is, at least you can go through the videos on my YouTube and you can actually fill those in. But again, I need to make the student version available. All right. So let's open up with some definitions. Let me check one more time, because I have that as a time. Let me check to see if we have any stragglers. Okay, so that looks good. Okay, I think we're good to go. So we have some definitions. First, we want to open up with this idea or notion of what we mean by an ordered pair of real numbers. It's going to be a pair of real numbers in which the order is specified, right? So you'll see this a lot. You have the ordered pair. Is this dude? It's charged. Yeah, my device is just totally throwing it's just throwing a tantrum. Let's try this again. So we have the ordered pair. I don't understand what it's not showing. Okay, let me try rebooting this. Okay, let's see. Yeah, there we go. Okay. So we have the order pair -3, 1, right? So that's basically that's like a GPS. It's telling us where this point is located. So if we were to start at the origin, it says from the origin you go left by 3 and then up by 1, right? So the first coordinate is our x coordinate. It tells us which way to move on the x-axis, and then the second coordinate tells us which way to move on the y-axis. Okay. So the set of ordered pairs of real numbers are identified with points on a plane called the Cartesian plane. So first we draw our positive x or x-axis, and the positive x goes off to the right. And our y-axis where the positive y direction goes up, vertically up. And then whenever we're plotting points, we start at the origin. For instance, if we're plotting 3, 4, we go right by 3 and then up by 4, right? So that's like the directions to that point. And so the x-axis with the y-axis, when we plot it in this way, it breaks the flat surface up, or it breaks the plane up into 4 quadrants, right? So our quadrant number 1 is this upper right-hand area, and it's everything going off in this direction. That's quadrant 1. Quadrant 2, if we go counterclockwise, is the upper left-hand portion, everything going off in this direction. Quadrant 3 is the bottom left, everything going in this direction. And quadrant 4 is the bottom right, everything going off in this direction. Right? So the x-axis with the y breaks the flat surface up into 4 quadrants. And sometimes you hear us refer to it as quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? That happens. Okay. We refer to the points on the coordinate, we refer to the point corresponding to the order pair AB as the graph of the order pair. So when we plot it, that's called the graph in the coordinate system. The notation P of AB designates the point P in the coordinate axis whose x coordinate is A and whose y coordinate is B, right? So P is just a label for that specific point. And then, plotting points, right? So for instance, if we wanted to plot the point A, which is 3, 1, if we start at the origin, we go right 3 and up 1. That's how we got to A. For B, if we start at the origin, it says to go left 2 and then up 4. So if we go left 2 and then up 4, you see B there. And then C says left 3 and then down 4, left 3 and down 4, you see C here. So on and so on, right? And again, if anything is not clear, I'm talking a little bit faster here because I feel like this isn't too terribly bad. I feel like you can digest this. But if anything isn't clear, you just have to get my attention. You have to stop me either in the chat or just feel free to unmute yourself to get my attention. Let me check the chat really quickly. Is there an access code? That's a good question. So you have to purchase an access code. If you go to Blackboard and you follow those prompts to get into Pearson, you have to purchase the access code, which runs about $120, just under $120. But there's no course ID, right? So a lot of students are like, well, what's the course ID? I was like, there's no course ID. You have to access it through Blackboard. I linked it into our Blackboard, but you do have to purchase the access code. Okay. So to develop the distance formula, we're going to start by just revisiting the Pythagorean theorem. So with the right triangle, the sum of the squares of the shorter legs is equal to the square of the longer leg, this Pythagorean theorem. And that leads us into the distance formula, right? So if you have your formula sheet, so again, to position yourself for success in my course, a lot of it is tied to your level of organization. And it's not about just having a copy of notes, because if you haven't gone through it or if you don't know what's there, it's not going to serve you. The learning comes from taking the time to create this stuff yourself, right? But yeah, so the recommendation is to have a notebook that's neat and organized, and hopefully in your neat and organized notebook, you have a formula sheet that you're always updating, right? So for instance, this is one formula that you can update your formula sheet with, Pythagorean theorem. Another one that's good to put on the formula sheet is the distance formula, right? So now let's see, now the next part is just context or backstory. You don't really need to know the next part. It's just so you can know where this formula is coming from, but you don't have to know this next part. So now, if we consider the point P and the point Q, and we want to find the distance between P and Q. right? So P is labeled as X1, Y1, Q is labeled as X2, Y2. And we want to consider this third point S, where the X coordinate of S comes from P and the Y coordinate of S comes from Q, right? So now, if we want to find the distance between P and Q, we can consider this right triangle made with these 3 points, P, Q, and S, or PSQ, however you would say it, right? So if we consider this shortest leg up here, that's going to be the distance between our X values, right? So as X changes from X1 to X2, we find that distance by taking the absolute value of X2 minus X1. For this shorter leg, that's going to be the change in our Y values. So that's going to be the absolute value of Y2 minus Y1, right? So this short leg is here. This short leg is here. So then now we're ready to use the Pythagorean theorem. If we want this hypotenuse, is going to be this squared plus this squared equals this squared, all right? And then if you take the square root on both sides, that's where the distance formula comes from, right? So the distance formula comes out of the Pythagorean theorem. Again, you don't really have to know that. And then also, when you square a positive, since it's absolute value, these numbers are positive. So then when you square a positive, you don't really need the absolute value. So that's where it just comes out looking like this. But yeah, so the distance formula comes out of the Pythagorean theorem. So again, you don't need to know that backstory. It helps when you know the backstory. It makes it much easier to process. And there are times when you deviate, you'll take that and be like, well, okay, if that leads to this, well, what if we, instead of going here, we did this, we did something different. But again, you don't need to know all of that. You just need to know how to use the distance formula. You just need to know how to use the Pythagorean theorem for our purposes. You just need to know how to use these. Okay. So then here we asked to find the distance between these 2 points. So I had a professor in grad school that was like, every time you use a formula, you write it down. That constant repetition helps to ingrain it in your memory, right? So here we're using the distance formula. So we would say the distance between P and Q, square root, we're going to say X2 minus X1 squared plus Y2 minus Y1 squared. Okay. Now, something that I like to do, undo this one. Whenever I have an ordered pair, I like to just go ahead and label it as X1, Y1, X2, Y2. For me, it just makes it easier for me to do my substitutions. So then if we go to find the distance between P and Q, it's going to be the square root. Now my X2 is going to be 3. My X1 is -2. Notice my use of parentheses. Thank you. Yeah, man, time goes really quickly. Like by the time we get settled, the class is halfway over. It's a blessing and a curse, right? It's a blessing because you only have to be here for like just a little bit more than 30 minutes. Is really 50 minutes. But a lot of that is like taking attendance, answering questions, me just procrastinating. I'm the king of procrastination. But then the drawback is, you don't have access to the professor as long. But it's really the way I designed it. You don't really need me per se. Like a lot of the learning is done independently. Now I'm there again as a record keeper and to just kind of answer whatever questions you can't figure out. But you have a crap ton of support. Pearson explains how to do each question practically. You can make use of the Ask My Instructor. So many of the homework questions have that feature where it'll send me a screenshot of your question. And I've had students using it and I'll make a video response and send it back. That's why you want to be subscribed to my YouTube channel with your notifications turned on. I also encourage you all to work together, right? So I don't know if you have a group me or something going, but something where you guys are like working together and chatting. I think that's a great idea. That resembles reality more so because when you get out of here, you're going to be doing collaborations. That's how you really do anything in reality, in my opinion. Also, I would encourage you to seek out the tutors, right? You've already paid for them. Their service is included in your tuition. So you've already paid for the services, so you definitely want to take advantage of that. So between me, Pearson, each other, on your own, and the tutors and the internet, one of those should click. Something in there should click where we can kind of position everyone for success, right? So, that's the long and short. Okay, so we said x2 minus x1 squared plus y2, which is this -4, minus y1, which is 5 squared, right? And we're taking the square root of all of that. Okay, so in this first part, double negative becomes positive. 5 squared is 25 plus -9 squared is going to be a positive 81. All right. So then I think that's going to be the square root of 106. Okay. Square root of 106. Style. All right, let me check the chat really quickly to just see how everybody's doing. Okay, the chat looks good. We got people falling off, but that's okay. Like, that was the agreement. This is remote asynchronous. It's okay, because I know this can be kind of intense, and it just builds going forward, right? So just do the best that you can. Just all I need from you all any given day is just to get your attendance credit, and if you get your stuff submitted, that's the bare minimum. Like, it's okay. Okay, this looks good. I think we got the same result. So another formula that you definitely want to update your formula sheet with is this midpoint formula, right? So the midpoint, the way I remember it is basically the average of the x's, comma, average of the y's. So the midpoint between 2 points, average of your x's, comma, average of your y's. That's how I remember it. Okay. So find the midpoint of the line segment joining the points. So again, the recommendation, every time you use a formula, the midpoint between P and Q, x1 plus x2 over 2, y1 plus y2 over 2, average of the x's, comma, average of the y's. Also, I personally, like to go ahead and label my points as x1, y1, and x2, y2. Okay. So if we're asked to find the midpoint, so the midpoint between P and Q, so my x1 is -3 plus 1 over 2. And then my y1 is 6 plus 4 over 2. So then -2 over 2 is going to be -1. 10 over 2 is going to be 5. So then the coordinates of the midpoint should be -1, 5. Okay. I did have a student, let me see. Over the weekend, he emailed about, there were a couple of questions. One was like, how do we determine if 3 points are collinear? And you can actually go back and watch the conversation there from my 9 o'clock this morning, where initially I said something to the effect of, there is a way using the triangle inequality, but I think I misquoted the triangle inequality where I said a squared plus b squared should equal c squared, but then we tested it and it didn't work. So then I was like, okay. An alternative is finding, which I'm more comfortable with, find the equation of the line through 2 points and then verify that the third point is on that line, right? To show that 3 points are collinear. So when we did that one, it worked. So then I had to go back. I was like, oh, the triangle inequality in this context is going to be, instead of a squared plus b squared equal to c squared, it's just a plus b equals c, right? So if this is like, if we say the distance between the distance a plus the distance b, if that equals the distance c, then we say the 3 points are collinear, right? So again, we have that conversation in my 9 o'clock. You would just have to kind of go back and, find that. Okay, let's keep going. Let me see the time. We got a solid 15 minutes. Let's keep going. So we got -1, 5, And then here's a type version of that. So an ordered pair A, B is said to satisfy an equation with the variables A, and B if when A is substituted for X and B is substituted for Y into the equation, the resulting statement is true, right? An ordered pair that satisfies an equation is called a solution. So when we're looking at graphs, that's just a graph of the solution set of an equation. Frequently, the numerical values of the variable Y can be determined by assigning appropriate values of the variable X. So for this reason, Y is sometimes referred to as the dependent variable and X is the independent variable. This just comes because typically we'll choose different values of X and then we'll find the corresponding Y value. So because the Y depends on the value of X, we typically call Y the dependent variable and X the independent variable. So the graph of an equation in two variables such as X and Y is a set of all ordered pairs in a coordinate plane that satisfy the equation. So when we're looking at a graph, that's just a graph of the solution set. So all those ordered pairs, it's like infinitely many times. There's infinitely many often? I don't know. But that graph is just going to be the graph of the solution set of the equation. Okay. Let's take a moment. Let me just go check the chat really quickly. Chat looks clear. People are dropping, but that's okay. So here we're and I think it's not only me, but I personally feel like math later in the day is just harder to do because it's later in the day, you're tired. Like for something like math, you kind of need to be fresh. Like when you just first thing when you wake up, but later in the day, it's just so difficult, especially after you eat. If you've eaten lunch and you're trying to sit down and make your way through this, boy, man, Pastor Pillow be calling me. I swear there have been times I'm in front of the students and I'm like dozing off while I'm talking. I'm like, God damn it, I'm so tired. And I would be laughing. I'm like, man, this is exhausting. But yeah, I feel like math is more difficult to do later in the day. I would have to like personally take a nap. And then as soon as I wake up, that's when I would do it, right? So here we're asked to sketch the graph of this, right? So the first way that we have for sketching the graph, is basically by plotting points. So we chose some X values. We want to find the corresponding Ys and plot the ordered pair, right? Plot the points that come up. So let's take a look at this. So we're basically making a table. We just chose these values of X. So we're going to find the corresponding Ys. So the first one is Y is going to be equal to -3 squared minus 3. So that's going to be 9 minus 3, which is 6. And so then this ordered pair X comma Y is going to be -3 comma 6. Okay. Then we have what? -2 squared minus 3. 4 minus 3 is 1. So that one looks like it's -2 comma 1. -1 squared minus 3. It's -2. I think that's it, right? 1 minus 3. Okay. And then the Y here is going to be 0 squared minus 3. So that's going to be a -3. Okay. And then this Y value is going to be 1 squared minus 3, which is -2. Okay. This Y value is going to be 2 squared minus 3, which is a 1. Okay. And then this one is going to be 3 squared minus 3, which is 6. Okay. So now we did this by hand, right? We got these ordered pairs, and then, on the XY plane, we will plot the points and then connect the points with the smooth curve, right? Now I wanna bring something, I wanna do a demo for you really quickly. If I can pull it up. Let's go here. Actually, I want this one. And let me see if I go like this. There it is. Yeah. Yes. Come on. That's want, you can do kind of have the one from earlier, but I'm gonna just refresh this and do some scratch, like behaves. Okay, let's reload and refresh. Okay, so now let's see this done in a TI 83 plus. Now, I'm doing this presentation with an 83 plus. There's also a site, if you want to like do free virtual graphs, you can go to galgebra.com. I think the other one is Desmos, DESMOS, something like that. If you just do a Google search for free virtual graphs, I use GeoGebra. That's one of the sites that I use for doing free graphing, or Desmos. But this is a TI-83 emulator. This is like the recommended calculator for a lot of these courses. So that's why, and this took me years to find, and I've been using it for years, and it just works great. So if I go to my y equals, right? And then I'm going to put in the equation x squared minus 3. And I'm going to use the table feature, right? So if I go to my table, now we're going to start when x is -3. Here, let's do it this way so we can see them together. So notice, when x is -3, y is 6. When x is -2, y is 1. So this table that I made, I did it in a TI-83 plus. You can also use Excel. Excel does calculations and formulas, right? So we can talk about that if you guys want. But you see where we did it by hand, and then you see it done in a calculator. So then next we want to plot these points. So what I'm going to do, on the second row where it says alpha, on the far right of the second row, it says stat. I'm gonna go to stat. I'm gonna go to edit, and I'm gonna basically put in these points. I'm gonna type them in. So let's see. We got a -3. Let me see. If I do negative, are you here? Come on. 3? No, 3. Let's see, negative. Why is that not working? What do I have to do to get that to work? Okay. Let me try this. Negative. What was the next one? -2. No, still nothing. Is it on? Let me see. This window. You're not gonna work. I don't understand why you're not working. But -2, no. There we go. Okay. -2. Now I think we're ready to get going. -1 and then 0. I'm basically plotting these points. 1, 2, 3. That's not a 3. Three. Okay. And then do the corresponding y. So we get 6, 1, -2, -1, 0. I always do this. 6, 1, -2, and then it's supposed to be -3, -3, -2, 1, and 6. All right. So we put these into stat plot. We basically plotted our points. So then we're going to go turn the stat plot on. The box is fine using list X1, L1, and L2. So then when I hit graph, maybe I didn't turn it on. Let me go to stat plot and turn it on. And now when I hit graph, not only does it plot the points, but it draws the graph through them, right? So our calculators do have, these calculators do have that ability. Or you can use GeoGebra or Desmos. It takes a little bit of getting used to, but it's there. We got a few minutes. Let's go a little bit further. So I think we got all of these results, and then we were able to generate this graph. So this is what we just did with sketching a graph by plotting points. We made a table with the X's and the corresponding Y's. We plotted the points, and then we connected those points with a smooth curve. And then as far as the intercept and the x-intercept and y-intercept, in order to find the x-intercept, we set y to 0 because y is always 0 on the x-axis and x is always 0 on the y-axis, right? So that's what this is saying here, how to find the x-intercept and the y-intercept. And so this example asks us to find the x and y-intercepts of the graph. Now, my recommendation as you go to find these, to do the y-intercept first. Oftentimes, I personally have found that the y-intercept is easier to find than the x-intercept. So let's just start there. So for the y-intercept, we want to set x equal to 0, right? So then that's, in this case, it's going to be y equals 0 squared minus 0 minus 2. So then you should be able to quickly see that this term goes to 0, this term goes to 0, and all we're left with is negative 2. So our y-intercept is negative 2. And then for the x-intercept, it's something similar. We're going to set y equal to 0. Okay. So then we're going to have x squared minus x minus 2 equal to 0. So here you are expected to have some level of proficiency with factoring, right? You are expected to know factoring. I kind of want to include this handout here, but it's I don't know that I have the time. Maybe I can pull it from my other one. So let's try to pull it from the 2 p.m. Okay, let me see. It's right for the slide like 21. This one. I want to copy. I'm going to paste it like here. Paste. Okay. So what this is a document on how to approach a factoring problem, right? So this is College Algebra 1 with lab. We do have a lab component where we go into further details about factoring, but for our course, you are expected to be comfortable with factoring. So whenever we have a factoring problem, these are the questions we want to ask ourselves. First question is, what is this, at 3 p.m.? I see the time. I'm trying to get those out here. But again, my device has been throwing a tantrum all day. So first question we want to ask ourselves, come on. This one. Let's see, I think I have to reboot this. I'm just trying to wrap this up and then we'll get out of here. Okay, there we go. Yeah, I don't know why. First question we want to ask ourselves, is there a greatest common factor, a GCF, right? So if there is a greatest common factor, you want to factor it out. Then the next question you ask yourself is, how many terms are we working with? Is it 2 terms, 3 terms, or 4 terms? So in this case, we're working with 3 terms, more specifically a trinomial like this. So where we can jump straight to the double parentheses, right? So here, this, we can go straight here. Where we have x and x. We're looking for 2 numbers that multiply to give us -2 and add to give us -1. And I think those numbers are what? -2 and a +1. -2 times 1 is -2. -2 plus 1 is -1, right? So then we apply the zero factor property. where when we have two or more things that multiply to give us 0, we basically set each one to 0 and solve. So we set each factor to 0 and solve. So x minus 2 equals 0, or x plus 1 equals 0. If we solve, we get x equals 2, or x equals -1. All right, so these are the x-intercepts. These are where the graph crosses the x-axis. Okay, so we got our y-intercept, we got our x-intercept, and I think we're going to end it there. All right. Does anybody have any questions that they need to ask before we go our separate ways? Any burning questions? All right, so if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. I'll see you Wednesday, same time, same place. Take care. Let me check the chat.